Arrays. Objectives. In this lecture, you will learn the reasons for arrays, explore how to declare and manipulate data into arrays, understand the meaning of array index out of bounds, learn how to declare and initialize arrays, become familiar with the restrictions on array processing. Discover how to pass an array as a parameter to a function, searching an array, discover how to manipulate data in a two-dimensional array. An array is a collection of a fixed number of components, all of the same data type. In a one-dimensional array, components are arranged in a list form. The syntax for declaring a one-dimensional array is as follows: the data type of the array name, an init expression, where int expression is any constant expression that evaluates to a positive integer. Accessing array components. To access an array, use the syntax array name followed by the index expression, where index expression is called the index and the expression is a non-negative integer value. The value of the index is the position of the item in the array. The brackets are the array subscription operator, and the array index always starts at 0. Let's look at a picture representation of an array. Here in figure 8-3, we have an array name with 10 integers values 0 through 9. Say we assigned the fifth position the value of 34. We can see that the number 34 is placed in the fifth position. We can add the elements of an array. For example, if we assigned list 3 10 and list 6 35, we can add up list 3, which is 10, and list 6, which is 35, and store that value in list 5, which is 45. Processing one-dimensional arrays. The basic operations on a one-dimensional array are initializing, inputting data, outputting data stored in an array, finding the largest and/or smallest element. Each operation requires the ability to step through elements of the array. This is easily accomplished by a loop. Let's look at an example. Giving the following declarations, we have an array which has an integer of 100 values. We can use the for loop to process each element of the array. Line 1 is our loop control variable, and line 2 is where we read each values into the element of the array. Array index out of bounds. If the index of our array exceeded the bounds of our array, we can say our index is out of bounds. For example, we defined an array element with 5 elements, 0 through 5. If we try to store information into a 6th element, our array is out of bounds. In C++, there is no guard against indices that are out of bounds. Array initialization during declaration. Arrays can be initialized during declaration. Values are placed between curly braces. Size is determined by the number of initial values in the braces. Let's look at an example. Here we have an array called sales. It has a double type. We can store the following values in the array: 12.25, 32.50, 16.90, the number 23, and 45.68. Partial initialization of arrays during declaration. We do not always have to initialize each array element. For example, given the following statement, list 10 equals 8, 5, and 12. This declares an array of 10 components and initializes list 0 to 8, list 1, the first position, to 5, and list 2 to 12. All other components are initialized to 0. Some restrictions on array processing. C++ does not allow aggregate operations. An aggregate operation is any operation that manipulates the entire array as a single unit. For example, one array cannot be assigned to another in order to copy each value. To do this, we would use a looping mechanism to copy the element values individually. Arrays as parameters to functions. Arrays are passed by reference only. Do not use the symbol ampersand when declaring an array as a formal parameter. The size of the array is usually omitted if provided it is ignored by the compiler. Constant arrays as formal parameters. Using const in the declaration of the formal parameter can prevent a function from changing the actual parameter when passed by reference. Integral data type and array indices. C++ allows any integral type to be used as an array index. Doing so improves code readability. Searching an array for a specific item. A sequential search or linear search is used for searching a list for a given item starting from the first array element. Compare each element in the array with the value being searched for, and continue the search until the item is found or no more data is left in the list. Two-dimensional arrays. Two-dimensional arrays are a collection of a fixed number of components of the same type arranged in 2 dimensions, sometimes called matrices or tables. To declare a two-dimensional array, the following syntax is used: the data type of the array name, the int expression 1 and int expression 2, where int expression 1 and int expression 2 are expressions with positive integer values specifying the number of rows and columns in the array. Accessing array components. Accessing components in two-dimensional arrays, we use the following syntax: the array name followed by the index expression 1 and index expression 2, where index expression 1 is the row, index expression 2 is the column, and these are positive integer values. For example, we have an array named sales. This is the row, and this is the column. So in row 5, column 3, we have this value 25.75. Now, if we look at a picture representation, we would see for our array where we stored in sales 5, 3, row 5, column 3, we will see the value 25.75. Two-dimensional array initialization during declaration. Two-dimensional arrays can be initialized when they are declared. Elements of each row are enclosed within braces and separated by comma. All rows are enclosed within braces. For number arrays, unspecified elements are set to 0. Processing two-dimensional arrays. Two-dimensional arrays are processed in the following ways. Process entire array. Row processing processes a single row at a time. Column processing processes a single column at a time. Each row and column of a two-dimensional array is a one-dimensional array. To process, use algorithms similar to processing one-dimensional arrays. Passing two-dimensional arrays as parameters to functions. Two-dimensional arrays are passed by reference as parameters to a function. Base address is passed to formal parameter. Two-dimensional arrays are stored in row order. When declaring a two-dimensional array as a formal parameter, you can omit size of first dimension but not the second. Summary. Arrays are structured data types with a fixed number of components of the same type. Components are accessed using their relative positions in the array. Elements of a one-dimensional array are arranged in the form of a list. An array index can be any expression that evaluates to a non-negative integer, must always be less than the size of the array. When passing an array as an actual parameter, use only its name, passed by reference only. A function cannot return an array type value. In a two-dimensional array, the elements are arranged in a table form. To access an element of a two-dimensional array, you need a pair of indices, one for the row position, one for the column position. In row processing, a two-dimensional array is processed one row at a time. In column processing, a two-dimensional array is processed one column at a time.